Yeah, sure. Hey
Okay.
everyone, welcome to our first meeting of this year. Let me just share my screen.
So yeah, today is the first meeting of 2023 for our coding club. Our main focus for today's meeting is to decide whether we want to go with website development or machine learning, since we sent out a poll like last week, and the results on the number of people that wanted to do website development versus the people that wanted to do machine learning were fairly equal. So we decided we'd kind of show like the best of two worlds in this meeting. So it'll be kind of split apart in half. The first 25 to 30 minutes of the meeting, I'll be explaining website development. And then the next 30 to 45 minutes, I'll be explaining machine learning. Yep. And then, so yeah, that's website development. And yeah, you can change the screen. So, okay. So first off, what is website development? So every website you see, whether it be like Instagram.com, Facebook, or even like It's Learning, for example, all websites that someone has built or maybe a team of people has built, and they all kind of contain the same few components. So the first part would be the front end. Now this is usually referred to as the user interface or the client side. So this is what the user sees when they open up your website. For example, if you open up maybe It's Learning, you might see all of your classes. You might see like the messages so you can message teachers or other students. So those are all the elements of the user interface or the design. Now the second part would be the backend. So the backend is there's usually a database running behind this front end. And what the database does is it obviously stores the necessary data for your website. So one great example of this would be if you were honest learning and you wanted to message a teacher, well, you would send a message to a teacher, and then that message would then get stored in a database, preferably on the cloud, and then the teacher would, well, the teacher's website would read from that database and see what message you sent, and then the teacher can send a message back. So that would go through the database again and then back to your website. So that's kind of what the database does. It holds all of the important data for so that each user can, data and get their UI updated based on the data that's being held in the database. Also, there could be like APIs. So, for example, for It's Learning authentication, if you were to develop an authentication feature for It's Learning, you could either develop that yourself, which would be pretty tedious, or you could import a package using whatever framework you're using. So if you're using a certain framework, there could generally be another authentication package for that framework. This is why you see a lot of common websites, they have Google authentication. It's not because every single developer is coding out Google authentication on their website, but the way this works is that every developer, let's say if you're using a certain framework, let's say Flutter, for example, which we'll look into the frameworks later, then and if I was developing on that framework, then I would simply just go get the Google authentication package, plug it into my app, change some code, and then I can use all the code that was written for this Google authentication package, and I can implement Google authentication into my app by not having to code it out the hard way. And then the last part about website development, this we probably won't focus on too much for our personal use cases, but it is important to consider when you're keeping in mind the large scale effects of website development would be security and hosting. So generally how this goes is you have to host a website. Uh, so in simple terms, let's say there is a set amount of domain names. For example, a domain name could be itslearning.com, and that's another domain name could be facebook.com. That's another domain name. So what security and hosting goes off of is in order to host a website, there are certain services you would use. Like, for example, a common one is GoDaddy. And you'd go on GoDaddy and then you'd purchase that domain so that, let's say, if I purchased Instagram.com, then no one else would be able to use Instagram.com and create a website with the title of Instagram.com. And the reason for this is, well, I can't purchase Instagram.com now because it'd be too much money. So, and I can't make a website that has the domain name of Instagram.com because someone else already purchased that domain. So now I can change this. So, and I also put a little picture, kind of, I can't, I don't know if it's too clear or not, but it kind of just sums up what I just said. So now I can change the slide. Okay. So the basics of web development, they all started off, and you guys, if you guys take maybe intro to software technology, I think that's what the class is at South, you learn some HTML, CSS, and JavaScript. So what are these three languages? As seen, HTML is a language. It's called hypertext markup language, and it allows for you, the developer, to describe the basic structure of web pages. So, for example, if I had a web page and I had a login screen on it, and then I'd fill out the text fields, and then I hit login, and it takes me to the next page, which could be the home page, right? Home screen. So that's what I was doing. It's just a basic outline for take for like one web page and its specific parts, and it's outlining those parts to stay together. Now, if everyone just used HTML to create web pages, the design and the user interface of it would be very boring. So that's why we use CSS for long form. It's cascading style sheets, and this is really used to develop the design. So you can add enhanced design effects with CSS, and this can play a vital role in the user interaction and the as well as the user experience. So, for example, if I was running a business and I had a web page for it, I wouldn't want to just make my website off of HTML because then not many people would buy from my business. But because when they go onto the web page, it wouldn't be that like attractive or appealing. So on the bottom right of the slide, I put a picture of HTML versus HTML plus CSS. So as you can see, you can build everything with HTML. CSS just helps enhance the styling of it. Now the final language in this package is JavaScript. Now, JavaScript is used for it controls how the web page behaves when a user interacts. So maybe basic things like clicking a button you can do with an HTML, but then when the web page has to be responsive based off what the user is doing, meaning that the web page can't just be displaying the same thing all the time. That's when you really use JavaScript to take in user input and adapt functionality into your web pages. So next slide. So why is website design such a big deal? So as I stated before, oftentimes this web page design, if you have poor design, then users won't enjoy interacting on your website. So this real world application that I stated before, if a business is being run, then and the users don't like going on your website, well, how are they going to buy your product if they don't want to go on your website? So this could affect like sales and marketing. So that's why when you are designing a website, it's really key to keep in mind how it looks and how appealing it is to appealing to the eye. So here are 12 basic principles of a good website design. So if I were to create a good website, should have a clear purpose. So for example, back to that business example, then my clear purpose is to maybe get users to buy a product. So that should be very clear. Users shouldn't be asking themselves why they're on this website. Or if you're on a social network like Instagram or Facebook, the clear purpose of that is to, well, socially expand and communicate with your friends and other people. So the purpose should be very clear. And then you should have progressive disclosure, meaning that each website it's kind of goes on with uh, purpose, but you know what you're doing in each step. So if I'm going to Instagram and I want to go to my messages, then it takes me to the messages page, right? Stuff like that. And then next thing, it also has to display quickly. I'm sure a lot of you guys have experienced it, but when you are on a website and it's kind of loading forever, it kind of irritates you a little bit and you won't really like the website that much. So that's another principle of good website design. It should be browser compatible. So nowadays, people use many different browsers. You can use Chrome, Firefox, Microsoft Edge, just to name a few. And if your website doesn't work on a certain browser that's used by millions of users, that might not be ideal for your website. The navigation should be intuitive. That's the next thing. So on any common website that you guys probably use, let's say for example YouTube, you know how to look at your recommended videos versus how to search up a new video. So if you didn't know how to do that, then the users wouldn't really like your website too much. So that is YouTube applying intuitive navigation. And then obviously proper spelling and grammar, that's pretty self-explanatory. The next thing is security. So let's say imagine if you have like an e-commerce website or again a business website, you want to make sure that, or even a social network, right? You want to make sure that users' passwords are not getting leaked for their addresses or payment details because that's very important info that you have to keep secure. Another thing is attractive design and easy to read. This just goes along to the skill of the whoever is designing or developing this website that they make it kind of appealing towards the eye. You don't want any like bright colors or anything. Uh, just like when you're writing an essay for school, you want to kind of lack out or leave out the bias, just to make sure that this website is kind of friendly to everyone. Next up would be no technological or functionality issues. So meaning if you had like a functionality that didn't work and users were unaware of that and they would expect it to work but it didn't, that would obviously irritate them a little bit and wouldn't be the best idea of good website design. It should be a maintainable website, so it shouldn't be like crashing all the time due to database errors or whatnot. And it should also be SEO optimized. Now, this means SEO stands for search engine optimization. So this might not be a big deal for our personal website development, but when it's scaling largely, if I'm trying to search up youtube.com and it's like the 10th result, that wouldn't be too ideal. So that's why optimization is a key principle for good website design. Okay, so we talked about HTML, CSS, and JavaScript. Those are most commonly the uh, basic front end website development languages that most people start off learning with, just because of its simplicity. But as website development has progressed, new languages, new frameworks have came out for special and better use cases. So the front end is also known as the client side, so you can use those words interchangeably, and the back end is also known as the server side. Right? So the front end is focusing on the user interface, so how the website looks for the user. And some popular frameworks in today's modern development world would be ones I listed below: Flutter, React.js, AngularJS, Vue.js. And .js just means it's a JavaScript framework. So it usually runs off of JavaScript, or like I think React runs off of TypeScript, which is a version of JavaScript. So now moving on to the back end of website development, known as the server side. This uses databases to store data, usually through the cloud or cloud computing. And how this would work is a great example of cloud computing, if you're unfamiliar, would be, for example, Google Drive. I can create a document or create a slideshow through Google Drive and then share it with maybe Arnav, right? So that way, both of us are the same document. And how this is being done is because that document is actually being stored in the cloud. That's essentially what cloud computing is. So, and that's the same methodology you use to maybe send messages on Instagram or any other social network. So, you can use a couple of different databases for this. You can use Firebase database, which is my personal favorite, developed by Google. MongoDB is another somewhat older database you can use, but still serves the same function. There's another one I didn't list on here. It's called Supabase. It's kind of somewhat new, actually. Um, Again, same kind of functionality to hold data on the cloud. And if you do know SQL programming language, which is the general programming language to communicate with databases, you can use a traditional SQL database, although those won't be on the cloud. So on the next slide, we'll see a view of how this all comes together. So this is what I've been trying to explain. the idea I've been trying to get at for the past few slides. So you have looking at the bottom, right? You have HTML browsers. So on the bottom, there's two computers, and those two computers represent each and every one of your computer at home that you're seeing. So you have an HTML browser pulled up, and then through the internet, you can see, well, you can see it goes to the uses HTTP, and that's how this data gets transported, and it goes to the server. So data, when you're on a web page, data is always being transported from your web page to the server. And if it is a dynamic web page, which we'll get into later on in this presentation, then as well as from the server to back to your web page. So in other words, your web pages are displaying data from this HTML, CSS, JavaScript code display, as well as important data from your server. And yeah, now you can move on to the next slide. So now this would be a general web development overview. So if I were to create a website, how would this actually work? First, the picture says create HTML files, and the picture is a bit outdated. You can use other frameworks like we discussed earlier, as well as creating maybe a backend too if needed. Then the next step would be to test locally. So whenever you're building a website, let's say if I'm building a website on React.js, you can download that file and open it up and run that file locally instead of uploading it. But when you do upload it, so after you're done testing that full browser application, when you do want to upload it, then you'll have to actually buy a domain, get a host, um, and then upload the files onto the web server, and then finally test it on the web server. So that's kind of how professional web development is done. Okay. One more key detail. Again, security and hosting. We won't be that much because normally if you're building a personal website or just a website just to learn web development, you don't really need to have much security, or you don't even need a host because you can just, like I said, run that website locally in your computer. But I just wanted to touch on this so that you guys have an idea for how this works in the professional web development world. So for security, there's even like a full cybersecurity, web security fields that you can get jobs in. So it's kind of a big field out there. But I just wanted to sum it up. Whenever you go onto a website, if you see the difference, sometimes if you see HTTP versus HTTPS, what that S stands for, that S stands for secure. So usually if you go onto a HTTP website, Google, if you're on Google browser, that's the one I use. I don't know about Firefox or Edge, but if you're on Google, it'll say website is not secure. So that means you probably don't want to put any private information on it, like your address, payment details, credit card details, etc. Uh, the way you can get HTTPS on your website is via SSL certificate. Now, SSL certificate, what it does is it ensures to the user that you are who you actually are. So, for example, if I were to go onto Instagram.com right now, and let's say Instagram.com didn't have an SSL certificate, which they do, so then I'd see not secure HTTP Instagram.com. And then that could be a bit of a warning sign because what could be happening is oftentimes hackers will duplicate a website so that users might go onto that website and and hackers can take in info. So if you guys ever have maybe like if you get an email and I forgot the hacking term for this, but if you guys, I think it's called phishing, something like that. But
Can confirm it is called phishing.
okay, yeah. So if you do get like an email in your spam email account, let's say, and then a hacker is emailing you and it says log on to your bank information. Sorry, log on to your bank account, uh, like to deposit $50 or something. What's kind of going on there is the hackers have made a duplicate of that website, of that actual bank website. So if you use like Bank of America, the hackers have made a duplicate of Bank of America, and they make it duplicate so well that you actually think it's Bank of America. So you go onto that and then enter in your details, and then well, you didn't enter your details to the actual Bank of America. You entered it to the hacker's website, and they can take the money from there and take your payment details. That's why it's important to use a SSL certificate to ensure that your website is actually the true Bank of America in this case. It says below, it protects hackers from stealing data from your web page's users. From your web page's users. So so moving on to hosting now, many services allow you to host it with an actual domain name. So domain name discussed earlier, it'd be like Instagram.com, for example. And the primary software, or not software, sorry, I can't think of the word. I'll stick with software. Primary company that allows you to do this is GoDaddy. And if you sign up on there and if you have a website which you have fully developed and tested locally, you can actually put that website with the actual domain name on the actual internet on the web. So then no one else, once you purchase that domain from GoDaddy, no one else can make a website under that domain. And no one else can take that domain from you as you purchased it and it's yours. So next slide. Okay, now moving on to static versus dynamic web content. So I put two images on the screen and I'll kind of explain them right now. So static web content would be you log onto your computer, open a web page, and the web page goes to the server. And let's say it would take in data from the server and put it back into your web page, and that's it. So you just see that ending. For a dynamic web page, there's actually one more step to it. And what happens is you open up your web page, and it reads data from the server. That data is then outputted uh, onto your web page, and then you can also, and then it keeps kind of goes on to where your web page is constantly reading data from the database, and your database is constantly outputting that data onto your web page. This is generally how chat applications work. For example, if I was to message one of you guys on any social media platform, then my web page, my computer, has to read your message from your computer. And how it does that is it reads it from the server because your computer sends it to the cloud web server. So my computer reads it from your server, and then your server then and then let's say if I message something back, then my computer will take that data, put it into the web server, and then you'll be able to see it in real time. So that's how these web servers work. So with that being said, most of these web pages you guys are on today are probably dynamic web content, just because most web pages do need to go in that loop and keep fetching data back from the web server. Okay, so I have this demonstration that I've prepared with Flutter and Firebase. So Flutter being a front-end application, Firebase being a back-end application. But I'll show that at the end of the meeting if we still have time. So Arnav will go ahead and show machine learning and artificial intelligence now.
So, I mean, most of us have heard about machine learning because of stuff like ChatGPT and Stable Diffusion. But the official definition in academia is the study of algorithms that can improve their performance at some task with some experience. There's also a definition for learning in general. This was given by Herbert Simon. He's a really big guy in academia, especially in psychology and stuff. So according to him, learning is any process by which a system improves performance from experience. So essentially, according to him, machine learning is real learning by his definition. So traditional programming, what we usually do is we feed in data. We feed in data and we give a program to the computer, which can then use that program to calculate the output based on the data. So for example, something like, let's say, Desmos, your data would be your input value, your program would be the function, and the output would be the function value. Machine learning basically takes this and it reverses it. So what you're doing is you're giving it the data and you're giving it the output, and the machine learning algorithm is coming up with the rules and the program that you need to apply on the data to get said output. So what do we use machine learning for? Machine learning is used when human expertise does not exist, when humans can't explain their expertise. So this is when for speech recognition, for let's say weather detection. So I'm pretty sure Google does use machine learning for detecting what the weather is going to be. And also when models need to be customized. So for personalized medicine, stuff like that, machine learning is useful. Of course, it isn't always applicable. So for an example here, there's no need to learn how to calculate a payroll. So it's not like a magic pill that can be used for everything. It does have niche use cases. So here's actually this is actually an example that if machine learning is chosen to be what we're learning, this is what the first thing we're going to do. So this is a classic example. It's called MNIST. Basically, they give you 60,000 images of handwritten digits from 0 to 9, and you have to write a machine learning algorithm to classify that. So for example, here you can see that this two, it's actually very difficult to distinguish. For us, it's easy because we're humans and we've seen this thousands and thousands of times. We know this is obviously a two. But if you wanted to write a computer algorithm to detect what a number is, this would be on the border edge between 2 and 3. It would be very difficult to distinguish. So for example, here again, we know that this is a 7, but looking at it, it could also be a 1. So it's a very tricky task to do with just base code, like if-else statements. It's a very tricky task, which is why it's commonly used in machine learning. So here are some more examples of tasks that are best solved by using machine learning. So facial recognition on your iPhones, on your Samsung phones, that's usually always machine learning. Again, handwritten digits, classifying them, classifying medical images, generating images, so stuff like stable diffusion. That's also done with machine learning. And it can also be very helpful for recognizing anomalies. So if there's an unusual pattern that deviates from what usually happens, it might be difficult for a human to identify in real time, but it would be trivial for a computer. Here are some sample applications that machine learning has been in since like 2010 for a very long time. So web search, Google uses machine learning in their search algorithms extensively. It helps, it's called retrieval. It helps them pick what the best result would be for a certain query. Computational biology, finance, e-commerce, robotics is a very big field machine learning is quite active in. Space exploration, information extraction, social networks. TikTok's recommendation algorithm is very much based in machine learning, same with Instagram and Facebook. So machine learning is being used everywhere right now. It's a huge field. So this is another definition. This is a definition for machine learning. It's a field of study that gives computers the ability to learn without being explicitly programmed. And as you can see, this definition is all the way back from 1959. A lot of the techniques that are used now have been around for a very long time. I'm sure all of you know about Tesla's autopilot feature. So this is a very rudimentary model back in 2013, and this was developed by UPenn. Basically, it has a giant camera on top. Actually, in the next slides, probably. Yeah, so they have a giant camera on top, and they use that to drive the car. Now in Tesla, of course, it's like small, very small 8 cameras around the car, I think. So that's just how far technology has come since 2013. And machine learning is used in all of these again. So there's 3 main types of machine learning algorithms. Supervised learning, unsupervised learning, and reinforcement learning. So what supervised learning is when you have training data and training labels, and they're explicitly stated. So you have an X and you have a Y. So something like MNIST, where you have the image and you have the number that the image is, that would be an example of supervised learning. Unsupervised learning is when you only have the data, but you don't have any of the labels. So what this is usually, unsupervised learning, the most common task is something called clustering. So you're basically grouping You're making groups based on certain trends. So for that, you don't actually need the label. Semi-supervised learning is it's basically like in the intersection between supervised and unsupervised. So that's when you have a lot of training data, but only some of the data is labeled. We won't deal with that too much. It's usually not very useful. And finally, reinforcement learning, which is basically when you have a model that's teaching itself how to be better. So, for example, if it's basically like the same way you would train a dog, you tell him, you ask your dog to sit or to do a trick, and if he actually does it, you give him a treat. So that's basically what reinforcement learning is in a nutshell. So here's an example of another common supervised learning task. It's called regression. So you're given a set of data, X and Y data points, and you have to create a line of best fit to model the data. This is something that, if any of you guys take AP statistics, this is something you will do as well. So, for example, here you can see this is the Arctic sea ice extent in kilometers, and this is the year. It's an XY graph, and here are the data points that we have. So you can see this red line is the line of best fit that was developed to model this data. So with this line, you can accurately predict what the Arctic sea ice extent will be at, let's say, 2015. Even though you have no data points, you can comfortably predict what it would be. So this is just a linear line. The green one is what's more commonly done. It's where you actually model a quadratic line because that fits the data much better than the linear line. Here's another pretty common example, classification. So in this case, you have to, given a tumor size, you have to classify whether it's malignant or benign. So you can see there's a very common trend just simply based off of the size of the tumor. You can create a threshold and you can say if it's below this threshold, it's a benign tumor. If it's above this threshold, it's a malignant tumor. So I think, yeah, so this is where you would build the tumor. Of course, you can pretty easily see that it's not always accurate. So for example, here, even though it's below the threshold, it's actually a malignant tumor. And here, even though it's above the threshold, it's a benign tumor. But that's to be expected. Machine learning is almost never 100% accurate. But it's a pretty good model. It predicts 4 out of 5 for malignant, so it's pretty good accuracy. And this is just an example. This is another classification type. So in this case, it's one-dimensional classification. The only dimension you have is the tumor size. And in this case, you're given multiple dimensions. So here you also have the age of the person in which the tumor is present. So you can pretty here it's actually very accurate. You can create a line to distinguish between whether the tumor is malignant or benign, just simply based off of age and tumor size. But realistically, you'd have a lot more dimensions. You'd have stuff like the clump thickness of the tumor, the uniformity of cell size, the uniformity of cell shape, etc. All right, now unsupervised learning. In this case, you're just given a big set of data without any labels. So the goal of clustering is to find the hidden structure behind the X's. So you can look at an example here. This is the data you're given, a bunch of data points. And the goal of unsupervised learning is to be able to classify these into blue, red, and green. They usually clump together because they're similar, they're the same data. So it's you can pretty clearly see you can create a line of distinction between them like this to then separate them. Another use of unsupervised learning is to group individuals based on genetic similarity. And here are some other examples: organizing computing clusters, social network analysis, market segmentation, and astronomical data analysis. This is actually this independent component analysis is an algorithm that was developed pretty recently. So so what it can do is it has the ability to act as a Fourier transform. So if you have a crowd of speakers what you can do with independent component analysis is you can distinguish individual voices from each person. This is on unsupervised learning because you don't know which speaker is which, but it's able to piece it together. It's a very complicated algorithm, which we will hopefully get into. So it's just ICA again. All right, now reinforcement learning. It's when you're given a sequence of states and actions with rewards. So you feed the states into the model. The model outputs an action, and then you give the model a reward based on whether the action is something that you wanted or something that you didn't want. In this case, in reinforcement learning, the model is often referred to as a policy. So reinforcement learning, the use cases of this, you can there are a lot of use cases for reinforcement learning. You can train a robot to walk. You can, if I'm not mistaken, I'm pretty sure reinforcement learning was also used in training ChatGPT. So there's a use case as well. And here it's create assignment problem to play games, to solve mazes. So reinforcement learning is also a huge field. So in a nutshell, basically every modern ML algorithm has three components: representation, optimization, and evaluation. So representation is the training process when you're training the model to accurately represent a set of data. Optimization is also part of the training process, and that's when you're tuning the model to give an output that's what you want. So you do this with loss functions, stuff like categorical cross entropy, KL divergence, etc. And evaluation is the final step when you actually test your model and figure out how accurate it is. So these are just a bunch of basically use cases and what machine learning can help, what machine learning can do. So it can model numerical functions, it can model symbolic functions, it can model instance-based functions, and it can also create probabilistic graphical models. So these are actually the machine learning algorithms that are best suited to each task. We will, I'm pretty sure if machine learning is chosen to be the thing we learn, we will get into, I think, basically all of these. We will do linear regression, we'll do neural networks, we'll do SVMs, we'll do decision trees, we'll do chain nearest neighbors. So yeah, this is just a bunch of machine learning algorithms that are currently in use right now. And
Quick
then these,
question.
yes,
Isn't like decision trees what they used in like chess algorithms and
I don't think they used decision trees. I'm pretty sure they used I think they used Markov chains and they used Monte Carlo search trees. That's what they used. So yeah, these are as I mentioned, optimization is one of the parts of the training of the algorithm. These are some of the algorithms that are used for optimization. We won't deal with a lot of these. The only ones we'll deal with are backpropagation, which is a form of gradient descent, and we'll get into stuff like genetic algorithms as well and evolutionary computation. So this is what a general roadmap looks like if you want to implement a machine learning algorithm. So the first thing you have to do is you have to understand the domain that you're trying and the goals of what you're trying to do. After which you go online, you search, and you try to find data that helps solve the problem that you have. I mean, nowadays there's a ton of data everywhere. There's websites like Kaggle, and you can just search it up online. And more often than not, you'll usually end up finding a data set that you need, usually more than one. So that's where the second one comes into play. You select the one that helps you the most. So two different data sets could help you solve the problem, but one of them would help you make a much more efficient algorithm. Then after that, you clean the data set, you can trim it, you can remove, let's say, the examples that don't exactly fit what you want. Then you pre-process it, and then you feed it into the model. And then after that, you have to actually teach your model. You have to train it on the data. You have to make it learn representations. and then you test it and you interpret the results. So this is some of the stuff. We'll get into this much later after you guys have a introduction to machine learning and you know most of the basics. We'll get into stuff like clip guided image generation. So this is the techniques that were used for stable diffusion that were used for DALL-E 2. We'll train language models. We won't train any on the size of GPT-3, but we'll train small ones and you'll understand the algorithms behind GPT-3. We'll train reinforcement learning algorithms. We can teach, I'm pretty sure there's one where you teach a human how to walk, a human model how to walk. You can teach a cheetah to run. So there's a lot of stuff we can do with reinforcement learning. And finally, if time permits, this is something that I want to do actually. We use reinforcement learning with human preference on a very small scale. So this was the algorithm that was used to train ChatGPT and InstructGPT. I'm sure most of us have heard of ChatGPT. So yeah, we'll do that on a very small scale as well on the language models that we develop. Yeah, and that's pretty much the end. So if Joseph wants to show his demonstration, I think we have time for that.
Yeah, so I couldn't get the demonstration fully up and running. I'm not sure. I might be running into some error between like the database communication as well as getting back to the front end. But I can show you essentially what it should look like. So so back to maybe like shift your brains over to web development for a quick minute. So essentially this is how modern day web development would look. Right now I'm using Flutter. It's a UI toolkit made by Google to make like websites and even mobile apps. So I wrote some basic code here. And how this would work is this is the code for my front end. So this is, if you want to think about it, this is like my HTML and CSS, even though it's in another programming language. Which if we do get into website development and if we do use this UI toolkit, then I can teach you guys this language and whatnot. So how it should work is, for some reason it's not working right now, and I don't see any errors here either. The blue is just like suggestions, and then the red would be errors. So for some reason, something's not working right between the database and my front end, but that's all right. I'll just show you guys how it's intended to work. So right here, I wrote some basic sample code, which you won't really understand if you don't understand the programming language yet. But essentially, I have a text field, and I'm just prompting the user to enter in a note and then save that note in my database. So how would I access my database? I'm actually using Firebase, and Firebase is Google's real-time database. So back, if you guys remember what I was talking about, like real-time databases and holding that data from that web page onto a server, Firebase allows you to do that. So there is a step-by-step process to connect Firebase to your um, Flutter application. We can go over that if we do web and development. So right here, I'm using the Firebase database. So right here, okay. So I've created a collection, and if you are familiar with SQL, then you can think of a collection as of like a table, right? And then inside the table, I have a document, which would be like a column. And inside that, I have three fields. So ideally, what should happen is if you go here and I run the app and I fill it out and put Joseph, I just put my name, since my name is Joseph, 16 as my age, and then notes, I just put hello. And this should happen and should print this back to the UI as well as update here. So I didn't update here. This is just what I manually edited in. But this is how it would look. So for example, if I was to message something on my, if I was to enter a note on my application, on my front end, then it would, well, I'll do this manually since it's not working, but it would So this is what should have happened, but obviously you guys just saw I had to manually do it. So as you can see, this is kind of my database. This is the back end of the website that the user can't really see, but us developers can see it. So we can see right now we have one user, which is called Joseph. His age is 16, and his notes is Joseph says hi. And then another user, which his name is Test. His notes are Test, and his age is 15. So this I just wanted to show you guys how the front end and the back end kind of interact. Now, furthermore, if you were to use another application, for example, one project, I did something with Agora. So if you don't know what Agora is, oh, that's wrong. So yeah, one project I made a while back. It was kind of like something similar to Discord, and it had the common functionality of what we're doing right now. Actually, is video chatting, or just chatting without video. And I used Agora's real-time voice messaging system. And what I did was this would be a third-party application or like API, which I then so I didn't have to code out the specifics of being in a real time video chatting application with other users. I just imported my Agora API into well, I used Flutter for this project as well. So I imported my Agora API into the Flutter project, and then I was able to write some basic commands and run Agora from there. So usually if you're using a third party API such as Agora, it will also have another console. If I was to log in, I'd be put into another console. So this would be Firebase's console, so us developers can see. And then if I was supposed to use another API, this would be Agora's console, so that other developers can see that as well. But the users are only seeing the front end, so that's the client side. So users only see the front end, which in this case it would be just the text field prompting them to enter their note. So that's pretty much my demonstration. Sorry, I couldn't get it fully worked out. If we do choose web development, though, I can work on it this week and probably even present something to you guys even better. But since you guys are here, we went over website development and machine learning. I can pull up the slides if you guys want. Actually, I think I might have closed or no, I have them. Okay, so it's really up to you guys. We'll leave it up to you guys since you guys joined the meeting. So if you guys want, you can unmute or just type whether you want. And if you type it, make sure you type it in the chat within the meeting. Right, it's just so you don't take up chat space.
Just I think it would be better if we just sent out a poll right after the meeting.
We could do that, but then I feel like I just want the people in this meeting to decide because they actually like care to join the meeting and learn about them both, as opposed to someone that didn't really join this meeting and doesn't really like know what each one of them is. But we could do. It's up to you. I think I have more experience with website development. Arnav has more experience with machine learning. So depending on that, it would be
All right, let's just see what they say.
okay.
All right.
All right.
So yeah, it'd be
So
great if you.
Arnav said
All
website
right,
development, machine
now
learning.
there's more.
Okay. So it's kind of tied right now. If
Yeah,
you guys
if
want,
it ties up at the end, I
Jonathan,
mean, I guess
Trey.
we could just. All right, it's 2-1. If it ties up at the end, we could just send it out to the rest of the club.
Yeah, yeah. Is there one? I think Jonathan, if you're
Yeah.
here, he did say something earlier. Uh, I guess we'll just wait. Jonathan, he might be like away from his computer for right now. So,
I mean, we could
uh,
also just assume he wants web dev.
and then send out a poll. It's up to you.
He's typing. He's typing.
Okay.
Yeah, web dev.
Okay. So we'll
I
send out
guess
a
we'll just
poll.
send out a poll. Yeah. So it's
Yeah.
currently 2-2 then.
Yeah. I guess would it be reasonable to do both? Kind of like what we did right now. I think that'd be, or one thing we could do is instead of doing them both, we could just do one after the other.
We could do that. Yeah. Let's send it out to the club, and if
Mhm.
that ties up again, then we'll do that. We'll just do 1 week web dev, 1 week machine learning, something like that.
No. What I'm saying is, or we could send one out to the club, and we could just ask them, do you guys want to do, or yeah, we can just ask them, do you guys want to do like web development for a couple weeks, finish that, and then do machine learning for a couple more weeks and finish that.
So like as a
Or
third option.
yeah. So I think we should do that because everyone's been kind of 50-50.
Okay.
That'd
Yeah.
be like
Yeah. We could do
it's
that. What do you guys think?
yeah, Jonathan. Thank you for sharing your trinket project. That looked pretty nice.
Yeah. I think we could. Let's just add the third option of doing both.
Yeah, because there's no reason to exclude. I mean, we have a whole semester until
Well, I
May.
mean,
Club
we
officially
we
ends.
could. I mean, Malu does have a point though. If we keep splitting between both, it'll be hard to go in depth into either.
No, I was saying like uh, we finish one unit completely because we have from like right now January to we might take a break off for exam seasons. And this
Hmm.
is also up to you guys that are in the meeting. So if you guys have opinion, just unmute or type it in the chat. Uh, but I'm saying we could go because we'll probably do 2 units in the semester. So we could do website development for maybe like 1 month or 2 months, and then do machine learning for the next 1 or 2 months, and that'll take us up to the end of the semester, or at least like April exam season, which we're probably planning to like cut off meetings because to study for like AP
Yeah,
exams,
AP exams.
SATs,
Yeah.
whatnot.
Yeah.
I guess we could spend like up to 2 months.
Do you want to add that as a third option, or just
Uh,
because
your
I mean,
motto is like against it.
if they ended up tied anyways, even if we send out a poll after, that's most likely what's going to happen anyways. Yeah, we are doing it standalone. So
Yeah,
we'll do web dev for 2 months. We'll finish the unit of web development, and then we'll move on to machine learning.
yeah. Um, because if we switch like one week, another week, that kind of be confusing for the brain. Okay,
Well, I think Madhav wants one for the entire semester.
um, I guess, but we do have to keep in mind like other people's considerations as well. I think
Yeah, I
your
think yeah,
comment is
we'll
good.
just send it out and see what happens.
Yeah, just send.
Let
I think it's
I
best
think
to send out a poll.
yeah, let's try and figure out a way to
That's
basically
all.
represent. Yeah, I think we'll send out the poll and you guys can vote again in the poll, just so we have your guys' opinions as well.
So our poll will look something like this. Use what do you know what RCV is? I'm not too good at Discord, or William might
I
know.
I do not know what RC. William, do you know what RCV is by any chance?
Ranked voice voting. Ranked choice voting. Wait, what's Madhav, could you like explain that?
So basically, you can pick what you want the most, what you want the second most, and what you want the least. And so it is,
Oh,
Oh, I see. Okay, okay.
and so you need to hit 50%. So if one doesn't initially hit 50%, like the least popular option, like their second choice will count as their choice. So like their each of them has to pick their second choice, and from that, there's gonna be like one that's guaranteed to hit 50%. So that means like if people like 40% like something, 60% hate it, and then 20% are iffy, or like in the people that hate it are split, it won't get selected. This thing.
Okay. Do you know how to implement
I
that
think
onto Discord possibly?
we have to do it to Google through Google Forms, I think.
Yeah, that could be another option. So, uh, I think, yeah, I think it's best to just send out a poll asking if we want to one either website development or machine learning for the whole semester, or we can split it up in two and do website development
50-50.
for 2
Yeah,
months.
I'm not sure if we really need RCV though, because I doubt we're gonna have too many people voting. Maybe at most like 20 people.
Yeah.
It's probably gonna be closer to like
Just
10, 15. So I doubt we're gonna need ranked choice voting.
so yeah, I think we'll just have three options. If you want to have
Yeah, I guess
web
that makes
development,
sense.
yeah.
Yeah,
So okay, we'll send out that poll shortly. Other
yeah,
than
and
that, do you
if
guys have any?
possible, it would be great if you guys could just vote, so we have your opinion as well.
Yeah. So I think this meeting's chat closes once everyone leaves the meeting.
Yeah,
But I guess that's pretty much it for today's meeting. Thank you everyone for joining. We'll see you next week on the 21st, I believe. Yeah.
yes. All right, we'll see you guys next week. All right, have a great day, guys.